So once again, as I said, my name is Yanulua, and for this Learn with Peer program, we'll be looking at networking. So we'll be discussing a couple of few things to get started with networking, what networking is all about, how networking relates towards a cybersecurity professional, and we hope by the end of the program we'll understand networking better and we'll be able to do our work as cybersecurity enthusiasts better. So the first thing we always encounter is to ask ourselves, do I need networking as a cybersecurity enthusiast? As a cybersecurity enthusiast, well, most people say you can do your work as cybersecurity enthusiast without knowing networking. Other people say you have to know networking. The thing is, it really depends on how good a person you want to be at your job. So knowing networking is a basics. You have to understand how the computer work. Most of the work you're doing as a security enthusiast is secure systems, learn frameworks. So you have to understand what networking is, how the network connect with each other, how everything works together before we can go ahead and interact with them. So before we start, I want you to ask yourself this question. Do you need networking? Do you need to understand networking? And if your answer is yes, let's continue and start. If your answer is no, well, let's wait to the end of the program. Then you ask yourself again if networking is for you. So we'll start with a brief introduction to networking. Earlier today, I sent an outline to the group. And for today, we'll be talking about the decimal system, IP address, protocol services, and OSI model, and the likes. So those are the things you should expect to learn. And I hope to make myself as clear as possible. If you have any issue hearing me or you have questions, please kindly drop them in the chat. So we'll start with day one. We'll start with discussion, the introduction. So the binary system, and almost every one of us has definitely seen an IP address before. We have been hearing the phrase IP address. We have interacted with IP address. So we'll try to explain what it means better. Are the slides shareable? Yes, I'm going to share the slides after the presentation. So let's continue. Let me share. I'll try to open up a terminal and share this. Let me. So is my terminal big enough for you guys to see? Okay, thank you. So before we start, let's look at something. I'm sure most of us have seen something like this before. Uh, we have seen something like this address before, like something like 192.168.43.45, and it is referred to as an IP address. So an IP address is basically like the address of a system. The way systems relate to each other, you have the IP address, you have various types. Before we go into that, we're going to look at the binary system, how the binary system works. So the binary system, as opposed to the decimal system, the binary system uses base 2, and you know decimal system uses base 10. So in binary system, everything is in base 2. So let's say we have something like 11111111. We have something like this. We say it is in binary, and you're asked to convert it to decimal. I'm sure it is easy for us to go about and say this in decimal will give us 255. because we know the binary system consists of two symbols which are 0 and 1, and these two symbols are what compasses the binary system and how we work with IP addresses. So for example, let's say we have the decimal number 10 and we have to convert this to binary. You what we do is just divide by 2, then calculate the remainder to get our answer. So one so in the IP address, we'll be using binary system a lot, and because the IP address is a combination of 4 octets or 4 bytes, which is 32 bits, and that's what make up the IP address. So we have class of IP address. We have 5 of them. Guys, if I'm going too fast, please let me know via the chat. So we have 5 classes, and the classes we have the class A, B, C, D, and E, which are the classful when we are dividing the IP address based on classes. So we say for class A, we say they range from 0000 to 126.255.255.255. Now, as what I said earlier, I said we represent IP addresses in octets. So if I have 0.0.0.0, in reality, what we actually mean is we have 0 for the first octet in 8 places. So we have 0 to so in reality, when we have 0.0.0.0, converting it to binary system, we actually have 8 zeros dot 8 zeros dot 8 zeros dot 8 zeros. Same thing when we have something like 255.255.255.255. The same thing when you convert it to binary, you have 8 ones. Let's just say this is 8. You have them like that. So converting, knowing how to convert from base 2 to base 10 and base 10 to base 2 is actually very important to know when it comes to networking. And most of these things, I won't be going deep into them because we can actually look how to convert binary to decimal, how to convert decimal to binary. What we'll be focusing on throughout this training is how to use networking to do our job better, how it relates to our job as cybersecurity professional. So one of the things we'll be using most times, one of the things we encounter in our everyday job is something we call protocol, services, and ports. So I'm going to clear this. So when we talk about protocols, we say protocols are like languages, the way systems communicate with each other. So let's say you open your browser and you decide to go to facebook.com or go to google.com on your web browser. The web server on Facebook or Google has to understand the language your web browser is sending. So they have to understand each other to be able to communicate. The way they understand each other, the language they use to communicate is what we call the protocol. So protocol is simply the language used by systems to communicate with each other. And we have services. Services are things that run on a server. Obviously, services that run on a server, they are services we can request and we can query to get things. And ports are not like the normal USB ports. They are not physical ports. We are talking about network ports, which are on the system, which runs various services. So there are various ports you'll be familiar with. For example, we are familiar with port 80, which runs HTTP, 443 runs HTTPS, 21 runs FTP, 22 runs SSH, and the likes. So this port, HTTP on its own is a protocol. HTTP is a service that runs on port 80. So HTTPS is a protocol too. It's a web service that runs on port 443. FTP is a file transfer protocol. It's a service that runs on port 21. SSH is a service that runs on port 22 and the likes. So there is a long list. Actually, we have about 65,535 services and 65,535 ports, both TCP and UDP ports on a system. So, and these ports, we say port 0 to 1024 are the standard ports we are familiar with. Those are the ports you see regularly. Then ports 1025 upward, we call them ephemeral ports or ports you use to do they are non-standard ports. Let's just put it that way. So what to take away is we have to understand services, the way they work, and the fact that services run on a port. And although these services, like let's take HTTP for example, by standard configuration, we know HTTP runs on port 80, but we have to understand that these services are not by default set to run on, by default it's set to run on port 80, but they are not required to run on port 80. A network administrator or a web administrator may decide to move their own HTTP from port 80 and move it to port, let's say 79 or port 200, whatever they want. So instead of focusing on what port number it is, what we will be focusing on is how to query what services run on which ports and how to enumerate these services better. So we know the standard ports, we know they are standard, but we have to know that sometimes people configure things differently and things work differently. So about services, protocols, and ports, if you have questions, kindly drop it to the chat before I move on to something else. So throughout this training, we'll be working with some particular services, some particular ports, which will be part of our challenges. Then again, there's in networking, we have the OSI model, the TCP IP model. Well, the OSI model, it's divided in layers such that it makes us understand, it makes us, I have a question. Services uses protocol which uses ports, right? Yes, that's correct. Services uses protocols to communicate and a service runs on a port. That's correct. Then the OSI model, as I was saying, divides network into various categories, various layers, so we can easily understand how they work. So we said the OSI model has 7 layers. I'm going to list out the layers, then we'll talk about them. So I'm starting from top to bottom, and we'll talk about them as soon as I'm done. Yeah. So the 7 layers, starting from top to bottom, we have the application layer, the presentation layer, the session layer, transport, network, data link, and physical layer. So I'm going to try to explain each of them one after the other. Okay, I'll start again. I said the OSI model divides the network into layers, into 7 layers to be specific, so it can be easier to categorize how each layer function, how each part of the network function. And the 7 layers we have in the OSI model, starting from top to bottom, they are the application layer, presentation, session, transport, network, data link, and physical layer. So explaining each of them, the physical layer is what we see. There are things we see. There are things like the Ethernet cable, Ethernet connection, Wi-Fi, how things connect to each other physically. They are on the physical layer. Then the data link layer, talk about things like the hub, it is rare these days. On the data link layer, we talk about things like MAC address. These are ways systems communicate with each other. And earlier we talked about an IP address, which you say is something like this. For example, a MAC address looks something like, it is represented in hexadecimal, so we may have something like this. So as opposed to the IP address, which is 4 octets, the MAC address is 6, and it is used to communicate internally. Like, a MAC address is specific to a system. Now, by default configuration, the MAC address is supposed to be unique to a system. So to start with, you are just going to say a MAC address is unique to a system. Then the IP address. So on the physical layer, we say we have things like the Ethernet cables, your wife, just physical connections in general. Just on the first layer, let's say we have physical connections in general. Then on layer 2, the data link layer, we have things, that's where we have the MAC address. We have things like ARP, the address routing protocol. We have OBS, which are rare these days. So during the course of this 5 days training, I may be going over this really fast now, but during the course of this 5 days training, we are going to actually touch each of them, talk about them in talk about them further, then try to work with each of them and see how they work. So on the network layer, we say that's where we have the IP address. On network layer, we say we have the IP address. We have the switch. You have things like the router on layer 3. And on the transport layer is how your packet is being transferred from, how your packet is transported from one end to the other. So when we talk about network in general, we know it has to do with systems connecting to each other, systems talking to each other. So the way they talk to each other, your transport layer helps transporting your packet from one side to the other. Then the session layer helps by creating a session, creating nonce, encrypting information so you can communicate securely between two ends. And presentation layer is how your data is formatted, how it is presented to the user. Then the application layer is what we are most familiar with, like the IP address, sorry, your web, like the web browser, your FTP service, SSH. We are familiar with the application layer because we use them often. Like when you use your browser to go to a website, you are most likely interacting with an application layer. So the things like HTTP, FTP are on the application layer. So I have a question. Why is the IP address not in data link layer? On the data link layer, you're not necessarily connected to a network yet. Data link is, you have the logical link, and you have, why the IP address is not on the data link layer is because you may not be connected to a network. Let's say, for example, let me go back to showing my terminal and I'll try to explain this. So, for example, if I try to show my WLAN 0 interface, I have an IP address because it is connected to a network, so I have an IP address. But for this system, I'm not using internet connection. So if I try to do the same thing for my EC0 interface, you notice that although I don't have an IP address for this interface, I have a MAC address for it. So on the data link layer, the IP address is not on the data link layer because necessarily you don't have to be connected to a network, but your MAC address is unique to you, so you can still communicate with other systems if they can route your MAC address. So if you are not on a network, you don't have an IP address. So for you to get an IP address, you have to be on the network layer side of things. So if you're not on the network layer yet, you can't have an IP address. I hope that clarifies it. Then we also have the other one, which is TCP IP model. So what I will do is I will encourage us to read about the TCP IP model, to look it up. Then they are similar in what they do. Sorry. So as I said earlier, this is the OSI model. So the other model we have is the TCP IP model. And the TCP IP model basically has 4 layers as opposed to. So I have a question. TCP and UDP falls in transport layer. Yes, that's correct. The TCP IP falls in the transport layer. So when we talk about network, we say you send data. The message you send from the system is referred to as data. So we say on layer one, you have raw data which you want to send out. When it gets to layer two, it becomes a frame. When it gets to layer three, it becomes a packet. And when it gets to layer four, now depends on the protocol you are using. If you are using if you are using the TCP, we say you have a segment, but if you are using UDP, you have the datagram. So the transport layer is where you have TCP, UDP. So the transport layer involves the manner of data transfer like circuit and packet switch. So as I was saying, the TCP IP model, as opposed to the OSI model, has 4 layers, which are the application, the transport, the internet, and the network layer. So, yeah, and the network address layer, yes. So on the TCP IP model, you notice that some of the things on the OSI model are combined. Is anyone else having issues hearing me? Please, if you can hear me, kindly indicate before I continue. Anyone else? Okay, thank you. If you're having issues, kindly reconnect. It may be your network. So you notice that as opposed to the OSI model, the CSPI model is kind of concise and things are merged together. You notice that in the OSI model we have application, but in the TCP/IP model we have application too, but we don't have presentation and session. So the presentation and session layer is merged together, and they all form the application layer in the TCP/IP model. We still have the transport layer in both. Then the network layer of the USI model is referred to as the internet in the TCP/IP model, and the physical and data link layer are referred to as the network address layer in the TCP/IP model. So they are very familiar in the way they work. You can read about them. There are not much differences. The way the structure is, that's what makes them different, and you can look up the functions. They work similarly. So before we end up the session for today, I was talking about protocols we'll be working with. So to move ahead, we'll be having challenges for we have challenge for you have to solve each day. The challenge for day one is you attending the webinar. So if you are on the webinar for today, you have completed the challenge for today. So the challenge, what you are expected to do is the things that have been mentioned here, try to go over them, look how they work, because the challenge for tomorrow, you will need them for challenge tomorrow. So by tomorrow, we will send the first challenge in, and we are expected to solve the challenge tomorrow, then turn in your answer. We'll create a platform where you can submit your answer so you can monitor your progress. So if you have any questions, please start asking them now as I round up. I have a question as where is encryption and decryption of raw data occur? When we talk about the session layer, the session layer has to do with how your session is created, how things communicate, like how you have nonce and the like. So your encryption and decryption of data is done at the session layer, while the presentation layer has to do with how your data is formatted. I don't know if that answers the question. If you have other questions, kindly continue. So before we round up, I will say if you have not registered for this in the training, kindly do so. By tomorrow, we'll be sending you a configuration file which you'll be using to connect to our network to solve most challenges. So if you have not registered, kindly make sure you have registered to be able to get your configuration or connection pack. So could you kindly briefly go over the OSI model? So as I said earlier, the OSI model helps us categorize the network into layers that deal specifically with what the network, the way the network functions. So it's divided into 7 layers, which represents the whole function of the network. So starting from top to bottom, the application, presentation, session, transport, network, data link, and physical. I said the physical layer is things you see how your connection is made. You have things like your Ethernet cable. When you talk about things like your the bus topology, the mesh topology, how your network is set up, you are talking about the physical layer. Basically, how things are set up, how systems are set up to communicate with each other. Data link layer is has to do with that's the layer you have the IP address, you have other things. Are you guys with me? Okay, thank you. Data link layer is a lower layer to the network layer. That's where you have your MAC address. You have things like ARP, the address resolution protocol. It's a way lower protocols can communicate with each other. So and there is on the data link layer you have MAC address because you may not be connected to a network, but you have MAC address because it's unique to you. So the data link layer helps you route packets via the MAC address internally without having to connect to a network. Yes. Thank you, Edwin, for the answer. That's a great one. So then moving on, the network layer is where you have things like your IP address, where you have the switches, where we have routing functions. The transport layer is the place where you have the TCP, you have the UDP and the likes. So isn't ARP in the network layer? ARP works in in the network layer and in the data link layer. ARP works between the 2 layers, but we best categorize ARP to work on layer 2 because layer 3 has other functions like the switching, you have IP addresses and likes. But ARP works on both network layer, works on data link layer, depends on the setup you have on the OSI model. So as I was saying, that's basically what we'll be looking at today. It's just an introduction to the the things we mentioned, the TCP/IP, the OSI model, protocol services and ports, the IP addresses and binary system in generally. So what I will say is let's try to go over these things. If you have other questions or you have other contributions or corrections to make, kindly forward them to the group. So I have a question. Isn't the switch at layer 2? Well, the switch is considered to be at layer 3 because the switch is referred to as an intelligent hub. So we have switches that does routing functions these days. You have switches that act as router, they have routing functions. So the switch is categorized as a layer 3 device. It is not a layer 2 device. So the switch is at layer 3. If we are talking about layer 2, maybe trying to talk about the hub, which these days is rare to find. Even when we have up to these days, they are most likely switches. So the switch functions at the layer 3. If that answers your question. So as I was saying, if you have other contributions, corrections to make, kindly send them to the group so it will help every one of us to learn better together. And you can reach out to anyone. It's a community, so you can reach out to anyone, ask questions, talk with anyone on the platform. So I think we'll be bringing the meeting for today to a close, and we'll continue the discussion on the WhatsApp group chat. So also, before, make sure you are registered. I said earlier, we'll be sending a connection pack to your registered email address. So if you are not registered, kindly make sure you register, get yourself registered before tomorrow morning. We'll send out the connection pack, which will be used for practice, and the challenge for tomorrow will be sent in the morning so we can go over it and work and solve it before we have our webinar again by tomorrow's evening. So that will be all, guys. Thank you for attending. Register at DOH. No, I mean you should register via the link. Okay, give me a sec. I will share the link in the chat. So that's the link. If you are already registered, please don't register again. But if you have not registered, kindly do so. So make adequate preparations. Okay. Okay, so Moses, I don't know if you have something to say. Please unmute yourself if you do. So if you have any other questions, please ask them before we end the meeting. So, is it safe to end the meeting now? What we are learning tomorrow, we'll be practicing. What we are learning tomorrow, we'll be practicing the things we discussed today: the binary system, the decimal system, the IP addresses. Those are the things we'll be practicing tomorrow, and the challenge, the links to the challenge will be sent to the group. Tomorrow we'll be working on Try Me, so the link to the room will be sent to the group. The session for tomorrow will be at the same time. It will be 7:45 p.m. tomorrow. Then what happens if you fail to attend lesson? Well, just try as much as possible not to fail to attend. Try as much as possible to attend the sessions. Try as much as possible to attend the session. If you can't attend the session, try to reach out to one of the admins to tell them you'll be attending. But just try to make yourself available to attend the sessions, and try to keep up with the discussions in the chat, and try to check your email regularly. So if you send anything, you'll be able to note it to get notified, and we'll also notify you in the group. Can we push the time forward? Well, we'll put that in consideration, and we'll let you know if there's a change in time on the group. So are there other questions? If there are no other questions, I'd like to end the meeting here so you can put up your discussions on the group if there's any. Is the course on TryAcme? It's a room on TryAcme we'll be working with tomorrow. So the room on TryAcme we'll be working with tomorrow, the link will be shared. You go over it, you solve it. That will just be for tomorrow only. For the remaining days, we have other plans for you. That's why I said you should register so you get your connection pack you work with. So once again, thank you for attending, and we'll see you at the other side. Bye.